Let's start off with scalar product. So we understand that when we multiply a vector and another vector and we end up with a number, it's known as scalar product. Okay. Now, how do you represent this? Given two vectors, A and B. If I know that this is a dot product or a scalar product, I just have to put a dot. Now, how to find this? Well, if we have the information of magnitude of the vectors and the angle, we just use AB cos theta. That is, we are looking at magnitude of A into magnitude of B into cos of theta. Okay, so these are magnitudes. We don't take them in vector form. We don't talk about the direction. If we have the vectors in component form, remember component form, that is AI cap plus A2J cap plus A3K cap. If I have to dot it with B1 I cap plus B2 J cap plus B3 K cap, the result is A1 B1 plus A2 B2, again all these are magnitudes, plus A3 B3. All are magnitudes. They don't have direction. Okay. Now, let's define scalar product. The scalar or the dot product of two vectors A and B is vector A and vector B is the product of the magnitude of vector A and vector B and the cosine of the angle between them. As simple as that. Okay. So remember angle between vectors. I hope you guys remember the tail touching and all of that. So please learn the basics. Don't just jump onto the multiplication of vectors. Now, what does the result mean? So this is a very important question. It will help us understand the concept and we'll understand why a particular thing is used in a particular scenario. Why does we'll understand, if you understand the basic concept of whatever we are studying, then we'll get to decide if we have to do scalar product or vector product. Okay. Now, what is the contribution of a vector in the direction of the other vector is what the result of dot product gives. Let me show what I mean. So we are going to look at two vectors A and B. Now the projection of a given vector, remember projection? Okay, that would be the projection. That is, if I put a light, if I shine a light from the top, what would be the shadow of that particular vector on the another vector? As simple as that. Basically, the shadow of each vector on the other vector, basically. So this is the shadow of whatever you're looking at, the red one, that is the shadow of A on B. That's what it means, right? So the dot product between A and B is given by, yeah, this. Of course, it need not have to do with A putting a projection on B. It can be that vector B's projection or the shadow can also fall on A. And so that would be a result. Okay, so the projection can be on from anyone to anyone, right? Just have a look at this. Right? So that's about the projection of things. So basically, if I have a vector, right? I think I'll explain this within an example. So that would be better. Now, understanding the formula and also the concept using our magnitude and angle and all of that. So what we have here is AB and EF. So we have two vectors, AB and say this is EF. EF and AB. And the angle between them is 60 degree. This is 6 units. And this is 4 units. Now, the idea of projection is quite simple. All you have to do is put a dotted line, which is obviously perpendicular over here. And this, let me this would be your projection. So basically, if you think about it, what we have here is a random line, okay, hypotenuse. We know the angle, right? We just have to find the base, this particular length. That's all, as simple as that. So we have to figure out this length. Okay, how will we figure out? This is 60 degree. So this will be how much? Yes, we have to make use of cos. So basically, or let me go with the formula itself. So vector A dot vector B, or in this case AB and EF, some magnitude. So let me go with whatever we have. I'll go with vector AB dot vector EF is given by AB EF cos of theta. So AB is 4 units, this is 6, and we have, this would be cos of 60 degrees. So this is half. So basically 12. 12. Okay. Right. Now, so what is that we're looking at? We're looking at the projection of a particular vector onto the other vector. So the projection is 2 units and the original vector is 6 units. So 6 into 2 is 12. Okay. Now, same funda, that is a dot product between two vectors A and B, which are in component form, is given by 2i cap minus 3j cap plus 4k cap dot of minus 3i cap plus 2j cap plus k cap. So if I take a dot product, so we will end up with 2 into minus 3. That is, we have to multiply the coefficient of I with I, then minus 3 into 2 plus 4 into 1. So this would be minus 6 minus 12, and this is minus 8 units. That's how you figure out the dot product. So basically, what we are looking at is scalar product, wherein we are taking the magnitude of the given vectors, the cos of the angle between them, multiplying all of them. So when it comes to component form, it is the respective components, i's, j's and k's, they have to be multiplied, all in magnitude form. So basically, the dot product gives us the contribution of a vector in a given direction of the other vector, right? Of course, into the vector itself and so on and so forth. So projection into the other vector. Again, these are all not all definitions which are from textbook or something. This is an fundamental idea, or it is a base for us to understand things. A starting point, basically. So these are two examples of how to go about doing or finding the scalar product between two vectors given the magnitude and the angle, and this is component form. Okay, so copy this as and when we use it throughout your academic years, right? Even in your college and all of that, you will understand all of this better. Again, this is just an introduction. Don't dig too much into understanding this as of now. As and when you learn the concept, things will be clear.